there was a lot of coal being burned in England during the 1950s. I'm sure you guys know that. After World War II, we came back and made babies, and they went back and made babies, but they also went back and got their economy really cranking. So in 1952, London was overcome by this cloud of deadly smoky smog. And at that time, nobody really has thought that the atmosphere would make deadlier ingredients. The reason I put that one first is it reinforces this concept of atmospheric chemistry. The way that people dealt with pollution from coal burning is they made smokestacks to get the smoke higher. The idea was, is smoke killing you? We're the good guys. We'll just make the smoke go higher so it doesn't kill you. And everybody was like, oh, that's excellent. Great. We love smokestacks. The number one air pollution technology was the smokestack. Just get the smoke higher and you'll be fine. And really, compared to the alternative, that was great. And then in 1952, we realized, but then other chemistry happens and that stuff is deadly. This is when we learned that lesson. In a period of 3 days, something like 4,000 people died. Like, you guys have heard that London is really foggy. There's the famous clothing company, London Fog, and it's like trench coats and like rain jackets and stuff. That's a regional issue. In London, it is actually a thick marine layer. And so people were walking to work, and they're like, dang, the fog looks kind of great today. And they walk into the fog and they fall over dead on the sidewalk before they got home or to work. Like, there were dead bodies littering the street. No exaggeration. I don't think all 4,000 dropped dead on the street, but I mean to say that people were like coughing and wheezing and passing out like publicly. And everybody was like, oh, right, atmospheric chemistry. And all of a sudden, we started thinking about this in a totally different light. Yeah.
New analysis estimated that it was more around like 12,000 people died.
Okay. So I did not know that.
I don't know how
Okay. So number 26 is the smog lesson. And William was just telling me that he's heard the number was much more than 4,000, but in other ways of counting it looks a lot worse. Maybe 12,000 even. I don't know about that number. Number 27 is a couple of stars, how air pollution affects us. There's a couple things I want you to know up front. They may be something we've discussed before. First of all, there are a few simple and obvious problems with air pollution. Number one, air pollution is much more likely to kill you in this country if you're a minority. A black child is 4 times more likely to be hospitalized for asthma as a white child. And just so that we're clear, that's not a genetic issue. You see, everybody likes to pretend that this is not a racially divided nation. But the funny thing is, if you're black, you're more likely to be poor. If you want, you can blame white people, or if you want, you can blame black people, or if you want, you can blame no one. That's you, I don't mind, either way. But one way or another, many of us believe it's because of our history of segregation. There aren't a lot of black people with old money, if you know what I mean. Yeah.
Is it directly that air pollution is more likely to hospitalize black children than white children, or is it just the fact of black people being
Right, it's more likely to get you if you're poor.
And that translates to.
In a country that was not racially divided, poverty would strike all people equally. But in this country, your race is an unfortunate indicator of your chances of living in poverty. That could be a coincidence, of course. So let's get that out there. Yeah, so exactly. Because you live in urban areas or you live in places with cheaper real estate, because you're poor, then you're much more likely to be closer to a landfill or to a power plant or to a factory. And so air quality tends to be worse where poor people are, and unfortunately, in this country, minorities are more likely to show up in poor populations. They're disproportionately likely to be poor. And so that poverty costs something. Those of us who argue that everybody has the same access forget that we're not all dealing with the same diseases, for example. It's not a level playing field when your children are more likely to get sick and miss school, for example. Interesting little tidbit about air pollution. Another little tidbit about air pollution. There's these little particulates in the air. They're called particulates. It means like a little piece of something like dust or pollen or ash. And particulates often pick up an electric charge. Can anybody explain to me why that is, that it's easy for particulates to pick up a charge? Like static cling is more likely for small stuff. Does anybody know what?
Rub against each other and make polar charges.
Yeah. Right, thank you. So the reason that they're more likely to be polarly charged is they're more likely to be polarly charged. Excellent. Here's the bottom line. Because particulates are likely to have a charge, they carry things in the atmosphere that are polar, that are charged. I think that's why clouds are charged, but I don't know. I'd be happy to be wrong. They're also made out of water, which is full of molecular fluid. So here's the funny thing. Because we have particulates, they deliver other air pollution into your lungs. If you could filter the particulates out of the air, you would breathe less of the air's other pollution. Air pollution rides particulates. This is a key synergistic effect. Remember we talked about synergy? Where two ingredients together are worse than you would expect from just combining the single ingredient outcomes. Yeah, we're better. Yeah, you can say that there's a synergy of nice sounds, like a harmonic. There's also a synergy in the bad sense. Particulates are bad. Air pollution is bad. But when you mix air pollution and particulates, the particulates deliver more air pollution to your lungs, and even worse, particulates stick to water, and your lungs are wet on the inside. So when you breathe particulates, you increase the contact time with other air pollutants, and they enter your bloodstream more. If you didn't already know this, that's a key issue to write down. Remember, I'm only reading the bold part of my notes today. So remember that a huge issue with air pollution is the synergistic relationship between particulates and other pollution. Because of their static cling, particulates deliver polar pollutants into your bloodstream because they literally stick to the inside of your lungs and increase the contact time. Finally, why did we talk about this? Air pollution affects all the following: soil quality, water quality, and because air pollution changes water quality, it's especially bad if you're either breathing or breeding in water. So fish and amphibians suffer the most from air quality because they breathe and they breathe in water. Respiration and reproduction. Breathing and breathing in water. Anything that breathes or breathes in water will suffer disproportionately from air pollution.
Because it's like a larger effect once it's in the water.
Well, again, there's water in the atmosphere, and water rains out of the atmosphere. So air pollution is delivered back to the earth by water. And so you cannot have clean water if you have dirty air. It's not possible. Yeah?
When it goes up into the air, does it get cleansed like a little bit? Like some of like evaporative process to it? Like, it doesn't come up at all?
It does not appear that there's significant bioremediation in the air. And other than that, how would we cleanse? So most anything that goes up will come down. Essentially, air pollution is just water pollution waiting to happen when it rains. And it's pretty equal volumes, you know. There's not a lot of stuff that goes up and somehow is not pollution anymore. Finally, one of the last effects of air pollution that I haven't mentioned yet, impact on natural and man-made structures. Like rocks dissolve and trees die and bridges and statues get eaten up. What I really want to talk about today, though, is number 28. About the 6 criteria of pollutants. I wrote them here. Those 6. And does anybody know what it means to be a criteria pollutant? What are criteria?
Things necessary stuff.
No. Kind of, but not really. What's a criterion? A guideline. So what does it mean to say that these are the 6 guideline pollutants?
Like the big major ones?
They're not the biggest. For example, our economy will be most affected by CO2, which is not on there.
So it's the easiest one to over.
And it's not the most common. By pounds, CO2 outweighs all of those, probably all of those combined. No? Kind of, but not really. What? Some of them do, but that's not what it means. You're not wrong, it's just not what. The criteria pollutants are those which the government regulates. There are limits. That's the criteria, the government guidelines. In the 1970s, we decided that healthy air was important, so we said, hey, government, why don't you start regulating air pollution? And these are the ones that in 1972, 73, we thought were really scary. This is what America feared in the 1970s. You'll notice there's no CO2 on there because we really weren't that worried about climate change. We've never given government the right to regulate CO2. Get ready, there's going to be a Supreme Court battle about whether or not the federal government is empowered to regulate CO2.
Oil industry, that's tough.
It's tough, exactly. It's a naturally occurring gas. And the outcomes are not immediate, so you can't be like, he's sick because of CO2. We can say she's sick because of lead. We can say she's sick because of ozone. But we can't say he's dying from CO2. He breathes CO2 already in his lungs. So CO2 is not a criteria pollutant. The government does not yet have a federally defensible jurisdiction over CO2. It does have jurisdiction over those 6. That's why it's called criteria. There are limits, federal limits to those emissions. Okay, next. Everybody must know the following. the main sources, and this will come up so many times. Every time, please look up, every time you see electricity, I want you to think of socks. Every time